Guys, Jay at Broader Performance here. Um, this is a complicated subject, and I am honestly still learning things to this date. I did a little bit of just kind of quick math thinking about this. I was kind of curious how many converters I've built to date. I don't know how accurate this is. It's pretty close, but I've built about 1,872 converters, which sounds like a lot, but it's really not a lot compared to shops that just turn these things out. That's all they do is just turn out converters. But I'm not just a converter builder. I'm a transmission builder, and I do valve body design and things. And so I do a lot of different things, but anyways, the point is, I think myself and many people in the industry are still learning. So there's going to be, I'll do probably several videos on this as time goes on, but today we're going to kind of focus on the idea that, well, it's not even an idea, it's the fact that a torque converter is a fluid coupler. So what that means is it's using the fluid to basically operate the torque converter. So what we have to understand is the fluid matters, and I'm talking temperature of fluid, viscosity of fluid, pressure of fluid within the converter. All these things make a difference, and if you buy a torque converter from whoever, and even if it's a off-the-shelf converter or a custom-made converter, one thing the converter builder doesn't really know in your special situation is most of the time we don't know what oil you're running. We can make a suggestion, of course, but we don't know what temperature your transmission's running at. We don't know what kind of oil delivery the transmission is providing to the converter. So there's a lot of variables that a torque converter builder has no control over, unless maybe they built the transmission and provided the fluid or a fluid recommendation, and also insists on strict temperature control. That would be the only way to control all this. And none of us are really doing that. I mean, maybe some are, I don't know, but I never really heard of a person selling a torque converter and putting a lot of stipulations on things. I have heard of, and maybe you guys have heard of this, there's been a company or two that had or used to promote like really efficient converters for drag racing, like, I don't remember, like 98% efficient or something, something really high, which is high for a converter. And, but they would tell you, they would used to advertise this, but what they would kind of tell you on the back end is, look, you've got to have 100 PSI of pressure inside that converter in order to achieve this kind of efficiency level. And what's the reason for that? Well, that's what we're going to talk about today, because it's a fluid coupler, so the fluid matters. And the thicker the viscosity of the fluid is, the tighter the converter is going to be, the more efficient it's going to be, the less it will stall. I think one thing people don't realize about converters is, like we talk about, it's a 4,000 stall converter, or, whatever it is, 2,500 stall converter. Well, that's a variable number. That varies based on the amount of oil that's in the converter, the pressure, the viscosity, and also very much so with torque, load that's on the converter. That number, the stall number, I don't know that we should talk about them like that anymore. I kind of don't look at things like stall so much on the back end. That's what customers look for. That's what they know to check. That's easy to it's sort of easy to measure on the vehicle. It's actually not that easy to measure on the vehicle, but that's what people get obsessed with, is what the stall is. On the back end, I kind of think of it more of surface area, the type of pump, the type of stator, the clearance that's in it. I kind of think about things a little differently. Personally, I don't get obsessed over a stall number. Like, I have customers sometimes that they'll put a converter in, whether it's mine or anybody's, and they'll trans brake the thing in the driveway, and, whatever, say they have a number, they want 4,200, and they see 3,800 on the tachometer. Nope, no good. I'm pulling it out. It's going right back to the guy. Well, to me, that's not really the way to do it. And this is such a long, complicated subject. So I'm going to try to stay focused a little bit here. And let's talk about the oil delivery within the converter today, and just kind of focus on that. So occasionally you'll get a customer that will say, well, the converter's it's not coupling, it's not acting right, it's this, it's that, it's building a lot of heat. They just have a lot of problems, and you can't seem to satisfy the situation. No amount of restalls, or even sometimes different converters just make little to no difference. And I believe that occasionally what we run into, it's a oil delivery problem. We're not filling the converter properly, so the converter kind of gets air pockets and things in it. So the converter kind of gets aerated. And this can happen, and it's not, it's not all that uncommon. So just to show you something real quick here, this is a cool little diagram. Let's see. So if we kind of go through here, so it's got these, bullet points, 1, 2, 3, 4, 5, 6, 7. Okay, and if you refer to the diagram here, you can see 1, 2, 3. So it's explaining at these points inside the converter what's happening. Okay, so number 1, the impeller is driven at engine speed. Okay, so this would be the impeller. I call it a pump. This is basically driven by the flywheel, and this starts to pump the fluid. Okay, so what I want to point out is, okay, number 2, fluid is supplied from the valve body to the spaces between vanes. Okay, so in this area, this is the intake of the pump, and we'll listen to what they said very carefully. Fluid is supplied from the valve body. Okay, so this is where it all starts. The valve body needs to supply oil, and an adequate supply of oil for this pump to take in. And then the oil is going to come through, get pumped out the outside of these vanes, and it's going to come into here, into the turbine. And this is what is actually coupled. The input shaft couples into here. This is actually what drives your transmission and moves your vehicle. Oil comes in through here, comes out through the inside, and then it goes through, they call it a reactor, I call it a stator. Either is correct, whatever your terminology is. And then it returns back into the inlet of the pump, or the impeller, as they call it here. Just a kind of a little bit of a quick overview of where the fluid is flowing. But what I want to focus on today is not so much that stuff. I want to focus on the valve body delivering oil to it. And what we also have to understand here, this book is not talking about this, but the oil is also leaving the torque converter and goes to the lubrication system of the transmission. So we have oil leaving the converter. So if the valve body is not able to deliver enough oil to pressure, to fully, to fill the converter and pressurize it, the converter is just never going to work properly. So it wouldn't really matter who or where or what converter you bought. And some will still work better than others in the situation, of course, but to take advantage of any torque converter, you need to have a good oil delivery system. And I don't think anybody ever really thinks about that. I'm sure some do, but I think the majority of people just kind of take it for granted. And so that, we're going to talk about that a little bit today. So give me 1 second. Let's look at this hydraulic circuit. All right. So what we got here. Now, I don't care what transmission you're working on. This circuit is of a C5 Ford. But, it doesn't matter if you've got a Turbo 400 or a Powerglide or, whatever, AOD or, whatever transmission you want to talk about. We're just talking generics here today. Things are all basically the same. So you have a pump. Every transmission's got a pump. And so it takes oil in. And this red line here is the oil coming out. So what happens is you have oil going to the base of a pressure regulator valve. This oil is actually what moves the pressure regulator valve and regulates the pressure, okay? That's what this is for. And you can see a little restrictor here. And the reason that's restricted is so that you don't get rapid movements and oscillation of this valve. So the valve kind of opens and closes more smoothly. Okay, so that's why we choke that down. If you had no restriction there, this valve would tend to just kind of knock around and you'd see your pressure gauge kind of bouncing around a lot. I've seen units like that and I've fixed them by putting more restriction here. Sometimes you'll even hear this valve rattling and making noises and things if you were to not have a restrictor there or the proper size. So anyways, what happens here, so your oil sits here, and this comes back over, this comes over and starts pressurizing all your circuits to your clutches and everything else. So, if you have leakage inside your transmission, internal leakage that you wouldn't necessarily be aware of, and you wouldn't necessarily know from the pressure gauge a lot of times, if you're actually checking the pressure of the trans, if there's a lot of excessive leakage inside the trans, you'll kind of starve the system of oil that goes to the converter and to the lubrication system. And what'll happen is, so the way this valve is designed, when it's closed, it's allowing all the oil to go and satisfy all the clutches and the circuits. And then, at that point, once everything is satisfied, pressure builds up, this starts to open, and then it will start, oil pressure will start to crack. You see this regulated pressure here. This will start to crack into this circuit, and then this comes to our converter and lube circuit. So this is a converter pressure relief system. This is so the converter doesn't get over-pressurized. It's a safety circuit. Some race units or even some units, period, stock, don't have this. So if the cooler or something gets plugged up, it can overpressure the torque converter, and it can lead to things like converter ballooning, or it can lead to premature failure of the thrust and the crankshaft. That's another thing we'll talk about another time. Is you see a lot of units, typically Powerglides. Powerglides with the aftermarket shafts and things can be very restrictive, and they make a lot of pressure inside the torque converter, and they will just wear out your thrust on your crankshaft and just be killing engines. A lot of guys have experienced this. I've fixed a lot of glides that have had this problem. It's very common in glides. So anyways, this unit here has a converter pressure relief system. Most of your Fords do. C4, C5, C6, AOD, these all have converter pressure relief circuits. So the oil comes in. Now you also have this, you'll see. This is a front lube circuit, okay? So you're losing some oil here also before you get into the converter. So you come in, you fill the converter. Here's another important factor that we'll talk about in another video. Again, this is several sections of video, but to get into all this. But oil has to come in the converter and then leave the converter. And there's a lot of theories. Guys kind of have their own recipe. Some guys don't think about this at all. Other guys I know, allow good oil flow into the converter, but then they restrict it coming out a little bit in an attempt to keep the converter full and in an attempt to keep pressure in the converter. And these are converter builders that kind of understand this fill circuit, and what they're trying to do is protect themselves so that when they send a converter to a customer who may not have the ideal oiling system, their converter will still work pretty well. That all the oil pressure isn't just going to be dumped out of the converter, and the customer is going to say, man, what's wrong with your converter? It doesn't work worth the crap. It doesn't couple. It doesn't act right. It's just, this and that. So they're trying to protect themselves there. Because again, when we send you a torque converter, we do not know. I mean, you can say, hey, I got a C5 transmission. Well, that's good, but, I don't know, or nobody really knows what that oiling system is like. Did you modify it? Did you not? Do you have unusual leakage? What's your cooler like? Is that restrictive? Your lines? There's a lot of things that we don't know, and the only way to really know is to put, pressure gauges and flow meters on your car. I do these things on units that I dyno so that, I'm controlling it on that end, but I'm not controlling all the installation differences that can happen. So, that can be, another thing that you don't see. But again, I'm getting a little bit off topic. But so then this comes out, goes through the cooler, and then goes through the rear lubrication system. Okay. So what can happen? You cannot fully fill the converter. You can have oil flow going to it, and it may not be enough. It may be just dumping out through the lubrication system too excessively to come in and pressure the converter. Now, I gave the example of other companies saying that they wanted 100 psi of back pressure in the torque converter, which I think is excessive. Especially with a Ford with the larger hub, but that could prematurely wear the thrust out in your crank. But in a max effort race engine where the engines maybe don't last that long anyways, maybe this is not an issue, I didn't come up with this number, but a friend of mine felt like 80 psi was about the most you would want to see inside the converter before you start really putting excessive force on the thrust of the crank. He's primarily a GM guy. Those hubs are a little smaller than a Ford. Maybe in a Ford we want to be looking more like 70 psi, I'd have to do the math on this, but, I'd say as long as it doesn't go over 80, you're probably going to be okay, but I've seen units that are just cranking Powerglides in general, but I've seen units, pegging pressure gauges at 150 pounds, just way too much oil, and they're very quickly killing the engines. Something to watch out for, and what you can do to make sure you don't have this problem: tap a pressure gauge into your outlet line before you get to the cooler, and just make sure you don't have crazy pressure there. Now, that does not mean necessarily that you don't have, say the restriction is inside the torque converter or inside the pump. So the restriction is, say, back here somewhere, and you've got a pressure gauge here, and this rear lube and cooler flow very well. You could actually see very low pressure here and think you're okay, but the pressure inside the torque converter is actually very high because you're not actually measuring that. You almost have to know that within the converter and in the pump circuit that you are nice and open and free to trust this pressure gauge reading. But you kind of can, So like, for example, let's say you're killing the thrust in a crank. Your pressure here could be really low because it's all trapped in the converter. But again, I'm kind of getting off topic. I'm sorry, but I should script myself better, but I don't do well with a script. So basically the point I'm making here is all of this is important, and we need to know these things. Now, let's look at a valve body here. This is a prototype design that I have. I'm using this because it's simple. So, right here, this area here is this right here is what you're seeing. So this is where the oil comes in and pushes on this pressure regulator valve, okay? Now, this is the pressure. This is the oil pressure that comes in and goes and feeds all the circuits and everything, okay? So this valve is all the way closed right now. I know it's hard to see. I'm going to stick my pick in here. I'm going to open this. And you're going to see right away, I don't know if you can. I'm going to try to point to it. You see the valve is cracked open here. This little leg here, this feeds our torque converter. So after clutches are satisfied, then we crack open and fill the converter. Now, here's another phenomenon that can happen. High RPM and making a lot of oil flow. Here's another instance that could potentially be going on. What happens is, as more oil flow and pressure build up, this valve will open further, and then look what happens here. Now we have good opening going to the torque converter, but see, now we're open down here, and we're dumping off into here. This passage here basically dumps back into the pan, or into the filter intake circuit. So what can happen is you can get a siphoning effect. If this valve opens too far, even though we're good and open here, we have restriction here going through the converter and the cooler and the lubrication system. Here, we actually have a little bit of negative pressure happening from the pump trying to suck oil up. So the oil is going to say, ooh, I like coming through here better, path of least resistance, right? You've heard that a lot with electricity or water flow, oil flow, airflow, whatever. Path of least resistance. So when this valve opens enough, this can become a path of least resistance, and this can destroy our pressure and flow going into the torque converter. So this is something that could happen at high RPM. This could be happening to you. You know, maybe it's working great up to 3,000 RPM or so, but once that pump really gets rolling, you know, 5,000, 6,000 RPM or something, maybe we're actually at that point starting to lose pressure to the converter. You know, and so I know, you know, I already know what you're thinking. You know, what do we do about this? How do we know if this is happening or not? And on and on and on. Well, this is where life gets complicated. And please, for the love of God, don't start sending me a bunch of emails about how to modify these circuits and all these things, you know. I'm so overwhelmed with this stuff. This is why I'm trying to do these videos, so that, because I can't give all this individual attention to everybody. I hope you can understand that. But so anyways, you know, you can, you know, one of the things you can do, you can experiment and play games with, and I don't want to tell you to do things that could potentially harm your unit, because you've got to be careful with pressure regulation modifications, because you can overpressurize the unit or overpressurize the torque converter. You got to know what you're doing, and you got to be able to check the circuits. So don't go in heavy-handed and just try things. I mean, you can, but accept responsibility for what you're doing, because you could really damage something. So, you know, let's say, for example, I told you about this potential siphoning effect. And you say, well, all right, why don't we just get rid of this passage and make it all go through the converter, or restrict this, or these are things that possibly could help you, but again, it's going to be a game of balance, because too much is going to be too much and cause way more harm than good. So you can't just do that. I will do some experiments with this on the trans dyno at some point, and we'll kind of talk about, you know, how much oil and flow can we push through the system. You know, that, you know, to me that stuff's interesting. I don't generally have a lot of time to do a lot of experimentation with it, but I've done my fair share of it. And you know, you can change the characteristics of a converter by playing with these things. So, you know, sometimes when things go wrong, we blame our converter builder. But again, we have to understand, and the point I'm making today is, it's a fluid coupler. So changing the amount of fluid, the pressure of fluid, temperature of fluid, viscosity of fluid, all these things will change that torque converter. So sometimes, you know, I say to people, don't panic and immediately pull your torque converter out thinking, well, if I just did this or that, the car's going to be faster. Not necessarily. You know, I can't tell you how often I have, you know, a customer will say, hey, I want, you know, whatever, more stall, less stall, whatever it is. And they'll, right away, they'll panic. It's not right. They send it back. I do what they ask. They put it back in. I can't tell you how often it's ended up coming back, and I ended up putting the converter back to where it was originally. That's happened a lot. It's kind of interesting, but, one thing you got to understand, that this is not an exact science. It really is kind of a guessing game when you're picking a converter. And, you can say, well, in theory, yeah, whatever, 3,500 should be right. But maybe 4,000's better. Maybe even 3,000's better. People always think more stall, the car's going to go faster. Sometimes it's the opposite effect. You do get to a point where too much is just too much. And the car actually slows down. And that really seems to mess with people. I don't understand. That doesn't make sense. I got more stall now. Why did it slow down? I know something's wrong with that converter. Again, sometimes too much is just too much, guys. This is, if that were true, we would just give everybody a 8,000 stall converter, and send you on your way. Yep, you want the fastest ET? Here you go. But it's, not always about that either. We got street, a lot of times we're on the street. We got to contend with that. And, of course, RPM limit. Not everybody spins their motor at $8,000, as my stupid example there. But, so there's a lot of things to consider there. And I don't know, I think I've probably confused you more than I've helped you. But, so, if you're not having much luck with a converter or several converters, you may want to look into your oiling system. That could be something. So we want to get flow going through the torque converter. So here's another thing. I'm going to kind of finish up with this topic. We want oil to come into the converter, and we want some pressure. How much pressure do we need? That's kind of controversial, The more pressure you put in a converter, the more resistance it has. So that's going to make it more tight or efficient, if you will. But, because you're adding resistance and friction in the converter, it can also make it heat up more by putting a lot of pressure in it too. Which could be an issue for something that's on the street. Probably not an issue for, just a quick eighth mile, quarter mile run or something. Then, you're sitting around waiting for your turn again. But if you're getting to do, back-to-back passes and things, maybe temperature can become an issue, possibly. So there is definitely, I would say the more pressure you put in the converter, the more efficient it's gonna be, but it's also gonna lower your stall too, so you don't really want to have too much pressure in there. And again, I spent a lot of time talking about the thrust surface on the crank, so we definitely don't want to have that issue. And when you're talking, billet racing converters, they don't really balloon. But, stock ones that are kind of thin, those will balloon. Billet racing converters don't really balloon, They just pretty much don't. You'd have to have a serious pressure in there to have an issue with that. But anyways, we want to get oil in the converter, and we want to get it out of the converter. We want to have a good pass-through of oil in it, because the oil very quickly gets heated by the torque converter. So we want to get that hot oil out of there as quick as we can. And again, that temperature of that oil changes the viscosity of the oil and its coupling ability. So, like for example, if you have a trans brake, you can notice this on foot brake as well, but trans brake's easier. Let's say you're trying out a new torque converter, whatever. I've had this happen to me. Whatever, let's just say customer wanted a 4,000 stall, for example. They get in the car, they put the trans brake on, and they floor it. Tach jumps up to 4,000. And a second later, it's at 4,200. Then it's at 4,400. Then it's at 4,500. You'll see that the stall will just keep climbing. And the reason for that is the oil's getting hot. And the oil's getting thinner. So the thinner the oil is, the less efficient it is. The less efficient the torque converter becomes. So if you sit there on a brake for several seconds, and you've heard of this, guys with turbos and things, trying to get them to spool. They'll sit there on the trans brake for way too long, because you really only want to be on a trans brake for a few seconds, because you're just going to cook your transmission. You're just making tremendous heat when you're on that trans brake like that. But you can sit there for 20 seconds and, whatever. You wanted to stall at 5,000, it started at 4,000. And you can sit there and spool up your turbos and heat your oil and get your RPM to climb up to that. But, man, you're going to cook your transmission. That's not a good scenario. We really want to be up to that, whatever your goal is, a lot quicker and closer, because you want to be off that brake in really ideally 2 or 3 seconds. I mean, you could turn the brake on, but when you're at full throttle, you want to get off that brake as quick as you can, because you're going to cook that transmission. I've had transmissions come in here that are cooked, and people are bad-mouthing the guy that built it up and down. Oh, this thing doesn't last. What the crap? The guy doesn't know what he's doing. And you dig into the situation and you realize that, man, the guy did a good job. It's just they're cooking the oil in this thing, and they won't run a temp gauge and this and that. And that's an issue. Your transit is never going to last if you're doing that. So you got to get the right converter. You got to get the right stall. And your tune on your engine. Turbos these days, they run higher compression with them now, and they spool a lot quicker. They work a lot better like that, from my understanding. I'm not an engine guy, but, with the higher compression engines now, this is not as much of an issue as it used to be. These guys kind of have these things down better now, where they'll spool up a lot quicker, and they're not sitting on the trans brake for a minute. And that's, if you're having to do that, you got to change something. Start with playing with the engine. We were talking about power. I get this a lot. Yeah, converter's working good, but man, I noticed I've got more stall than I used to have. Car's running really good and everything. I'm not complaining, but the stalls kind of come up. What's up? These things kind of break in and loosen up after a while? No, not really. They can maybe if fins are starting to get bent and things like that, but that shouldn't happen. But what is happening is you're making more torque. So you're getting the engine more dialed in. Maybe it's the weather. You're getting later into the season and nice dense air is coming in and the motor's just making more power. That's generally what's happening. Not so much that, the converter's breaking in or anything like that. Other question I get a lot is, oh man, something happened to the converter. Oh, okay, what happened? Well, it's just, I used to have 3,500 stall. Now it's only barely stalling 3. They don't generally tighten like that. You're losing power. Oh, no, the engine's running good. Well, I understand it turns on and it's loud and it sounds impressive, but you're losing power. No, it's just losing stall. I'm telling you, something's wrong with the converter. Can't tell you how many I've had to cut open. Cut it all open. Oh, man, nothing's broken. Everything's fine. You're losing power, I'm telling you. And then they find out, the engine's losing power. It's generally the only reason that the torque converter starts tightening up like that, that I'm aware of. So it's a frustrating thing to know what's going on, but So just some things for you guys to realize and think about. Kind of a long video here, me rambling, but there's so much to cover in all this. And I'll do more. I'll pick this apart as time goes on. We'll do some experimentation with, looking at the flow meter and the cooler pressure gauge, and I'll kind of go over what I did or didn't do to the valve body, or even within the torque converter, or we could even try experimenting by putting, you could experiment with things by, if you're trying to put a little more pressure in the converter, you could put a little bit of restriction before you get to the real lube. You got to be careful with that, though, because you don't want to restrict oil to your lubrication system too much, because then you're just going to burn up your planetaries and things like that, which is another thing I've heard of with glides a lot, that, even C4s, too, they start to restrict these oiling systems, or, like early C4s, for example, have very restrictive and a crappy oiling system. C4s have a terrible, the 70s and ups were okay, but those ones from the 60s, those oiling systems were pretty terrible. And, you'll find you have, premature planetary failure, thrust washer failure, or bearing failure, or whatever it is. So you don't want to mess with your flow going through your lubrication system too much. What I generally try to concentrate on when I modify these circuits is I try to increase delivery of oil to the torque converter. If I'm good, my pressure in the converter and in the cooling system is, low, or not, let's not say low, but reasonable, and my flow's, pretty good or whatever, I can go and add more delivery to the circuit to try to push the envelope here, because you're gonna, like I said, we're gonna flush nice, fresh, cool oil through the converter by adding more delivery to it, helping it to work better, and then we're gonna have nice oil flow going through the cooler, try to keep things cool, and then lots of oil going to our lubrication system to help the transmission last. And that's the big advantage there. So, okay, guys, I think that's all I'm going to cover today. We're already almost 43 minutes into this, so appreciate you watching this. Let me know in the comments if there's aspects of the converter that you would like me to cover. Please don't bombard me with emails asking me what to do to your valve bodies and things like that. Or, if I know if you have this problem or not. I don't, without, seeing everything. You'd have to send everything in, for me to go over it. I'd have to cut open your converter. I got to look at your total transmission. I need to dyno it, measure things. There's a lot involved in having these answers for you, rather than just, hey, buddy, here's a recipe I'm going to hand you. I might be able to hand a recipe out. We'll do an experimental video on a transmission one day, and you can kind of sort of get a recipe idea, but, there's too many transmissions out there and too many variations to just do that. So anyways, guys, thanks for watching and supporting the channel.